Today we're going to begin where we left off yesterday. Writing logarithms as single, logarithmic expressions as single logarithms. My dog just about caught a squirrel. Okay, here we go. We have this rather complicated looking thing, and we need to write it as a single logarithm. We have a minus in it, so that indicates a division. So that becomes log of x minus 3, 4x minus 3 over x. And of course, there's a hidden base 10 in both of these, or all three of these. Okay, in this case, we have log 2 of z plus log 4 times log 2 of y. In this case, it becomes log 2 of z plus, the only thing we've done different here is we've used the power rule and taken this 4 and placed it behind the argument y. So that's the first step that we needed to do. Now, because this is a plus, the z and the y to the fourth are multiplied together. I'm going to close this door. There's just a slight breeze coming in that's a little cold on my back. Okay, we've got several things to do here. We need to move this 3, this power of 3 up here behind the x. And then we're going to have a multiplication and a division. So the first thing we do is we move this 3 to the power position. Haven't done anything on the rest of it at this point yet. These two, the x cubed and the x minus 2, are going to be multiplied, and then we're going to divide by the 5 in that respect. Now, we do not need to go ahead and distribute this at this point. Okay, now this means that this 2 is times both of these first two terms. So we're going to distribute that 2, which gives us this and this. Our next step, we'll take this 2, bring the power up here, take this 2, and we're going to have to take this 2 times that 2. So we have natural log x squared here minus natural log x fourth. We also took 2/3 times 9, getting 6 for the power here. And of course, there was nothing in front of this one. Now we're ready to start grouping these by multiplication and division. Okay, we have 2 plus items or 2 positive items, so those will be multiplied in the numerator. We have 2 negative items, so they will be multiplied in the denominator. So we've got the x squared, z to the 6th, and the x fourth, z to the 1st. Now, we can do some canceling. Z goes into z to the 6th, z to the 5th times. X squared over x to the 4th becomes 1 over x squared, because these two cancel out 2 of those. So this becomes our final solution in this problem. Once again, we've got a negative out here, but we have to take this 2 times this whole parentheses. Okay, you notice the negative is remaining because that shows that that's a divided term. So here's the 2 that we moved over using the power rule. So now we have a division, a denominator, numerator, and a numerator. So we've got log fifth of the x and the x squared minus 25 over log fifth of the x plus 5 squared. Well, x plus 5 squared multiplies out, or it can be simplified to x plus 5, x plus 5. X squared minus 25 can be factored to x minus 5, x plus 5. It's a conjugate. So now we can cancel these x plus 5s, leaving us log 5 of x times x minus 5 over x plus 5. Now, they're going to show you some steps in doing this that I do not care for. I would not do it this way myself. They're going to group these 2 negative terms in a parentheses, and that's just an opportunity for effort. That's a minus sign right there. So they're pulling the negative out of these, leaving them positives in the parentheses. I wouldn't do that. Here's their simplification of this part inside. They're saying these 2 are added, so they're this. What I would do is I would say I've got a positive for the numerator here, and I've got 7 for the denominator and 5 for the denominator. So I would go straight from this step to that step. Now, 7 times 5 simplifies to 35. And then 35 will actually divide into 560 16 times. But we're still not finished because 2 to the 4th power is 16. So we can simplify this log 2 of 16. Okay, here's our log 2 of 16. We said that 2 to the 4th is 16. So 16, we renamed it as 2 to the 4th. Okay, we've got a 2 of 2 here is 1, leaving our solution equals 4. And you don't have to show that step from here unless you just want to. Okay, so this big long thing that we started with here, the final answer is just simply 4. Okay, here's another one. We've got a power to move over. We've got a power to move over, and this is going to be a denominator. And we've got a power to move over, and that will be in the numerator. So we've moved the powers at this point. Okay. Now we're going to start. They just switched the order of these so the positives were next to each other. You can do that if you want to. I wouldn't. I would just know that this x squared and that z cubed go in the numerator. The y to the 1/2 goes in the denominator. Well, they took the 2 positives together first. Again, I wouldn't do that. I would have gone just straight down to it, because here's the x squared in the numerator, the z cubed in the numerator, and the y to the 1/2 in the denominator. Okay. Now, the only other change that you would make with this is you would change this 1/2 power to square root of y, because they don't really like leaving fractional powers in these as your final step. But either of these answers would be considered correct. Okay, now we're doing a little bit of review. Okay, we're going to take some positive numbers. We're going to let p be a real number. We're just going to review our properties so far. Natural logs, natural log of 1 is 0. Natural log of e is 1, because remember, this is log base e of e. Natural log or log base e of e to the p gives you p. And e of log e of x gives you x. The format for standard logs, anything of 1 gives you 0. And here's exponential form to go with that. Okay. Why is this true? Because if we change this to exponential, 0 is the power, b is the base, and the argument is the solution. Okay, b of b equals 1. Here's the exponential. Anything to the first power is itself. B of b to the p power is p. Why? Because b of b is 1 and p is your resulting answer. Okay. And again, here we've got a b of b, so x is the answer. And here's the logarithmic form of this. Here is some more review. Okay, if we take natural log of 2 variables multiplied, we break them out with a plus. Natural log, all we're doing differently here is showing natural log rules compared to log rules. But as you see, they work exactly the same way. There is no difference whatsoever. The division property is here. Okay, if we got minuses, we're going to divide our denominator. Positives would be numerator. Okay, natural log of x of p, you bring the p out front, and then you got natural log of x, or natural log of whatever it is. And that's the power property, where you bring this p out front, or if it's out front, you bring it back to the back. Okay, why is this? Well, because this means natural log e of e. Here, what do we got? Well, natural log of 1 is 0, because we have log e of 1. Anything of 1 is 0. Okay, in this case, it would be x plus y, because natural log of e is the same thing as log base e, which gives us the e of e. So we've taken this x plus 1 out front. The e of e is 1, so we get x plus 1. We're writing it as a single logarithm. Okay, we're doing just the opposite of what we were doing earlier. Earlier, we were expanding it. Now we're contracting them. Okay, we've got a numerator, a denominator, and a denominator. Again, first thing you do is you use the power rule, bring this third power back here. I would not do this rule. I would not do this step. I would still go straight to x over y to the 1/3 z. And again, I wouldn't do that step either. I would go straight from this step right here. I would go straight to that right there. Now, the only other thing we can do on this problem is we can change this y to the 1/3 into y to cube root of y. Again, I don't like this grouping thing. I think it's opportunity for error. I prefer to go straight from this step right here to that step right there. Now you need your calculator. We're going to be using it in just a moment. These are our standard disclaimers. Now, if we've got a logarithm that's not base 10, and you want to do computation with it, if you have a Texas Instrument calculator or just about anything besides a Casio, one of these Casios that I listed for you earlier, then you have to go through these steps. Now, this A in this case is typically base 10, although you could choose it to be any base you wanted. You could make 4 and 4 there, but there wouldn't be any point in it. It's easier to just use base 10. That way you just simply write the word log, and look what happens here. The argument becomes the numerator, the base becomes the denominator. Okay. Now, in the case of if I ask you to put this one, well, here's that log hidden base 10 over log hidden base 10. The x over the b, log x over log b. Now, in your calculator, you can enter that no matter what kind of calculator you got. Or you can enter this no matter what kind of calculator you got. Now, in an awful lot of final tests, they've given you a question where they put in some numbers for the b and the x, or numbers and letters. And then they ask you to give the answer in terms of natural log or in terms of e. Well, all they're wanting you to do is, instead of using log, they're wanting you to use natural log of x over b. Okay. And I put this star here because that's shown a problem that says convert this in terms of e, or a natural log, and they're looking for an answer like that one. Okay, now let's get, okay, hope this works. Log 7 of 15. The way they would have you do this is take log, whoops, I've got to back up. We have to use the fraction key. Put in log of 15, go down, then log of 7 equals. And I made an error because I didn't close my parentheses. So let's try that again. We'll put in the fraction, log of 15, close the parentheses, now go down, log of 7, close the parentheses, go over, get out of this, equals. And we get that value. Okay. Well, here we've got this. You see, it's the same. Now, I want to show you something else. This calculator, the Casios that I showed you, have a special key that the TIs do not have. The log base of argument key, right up here. Okay. This key, you just click it. In this case, we put in the 7. We use the arrow to go over, put in the 15, and we hit the equal sign. You see how much simpler that is with these calculators. That saves you all of these steps. 1, 2, 3 steps. Okay. And in a complicated problem, that's kind of a big thing. Okay, let's go on to the next problem. Log 5 of 0.3. I'm going to clear this. Now, we can do that. Or we can do this. 5 over 0.3 equals. Okay. Much simpler if you have this log base of argument key. Okay, now use the change of base formula to evaluate log 4 of 80 by using base 10. Okay, now they're wanting us to use base 10. Okay. Well, so what they're doing is they're saying log base 10 of 80, log base 10 of 4. Well, that's just plain log. In the computer or in the calculator, you could use this key right here, fraction, log 80, close the parentheses, down, log 4, close the parentheses, equals. Or you could just do this because log is just that. So we take log 80, log 4, go over, and 80 equals. Now let's go ahead and finish this over here. Over here, doing it this way, manually anyway, you'll get this answer. What they did was they took log of 80. They didn't even have a fraction key. They took log of 80, got that number, then they divided it by log base 10 of 4, which is this number, and voila, you can see what it looks like. Now, how many steps did we do from this to that? 1, 2, 3, 4 steps. And kind of a pain in the behind steps when you can just do it this way. Okay. Now I have 2 grandkids who are in college. One is a freshman, the other one's a junior. I've got another grandkid who's taking calculus in high school right now. All 3 of them, even though they're allowed to use graphing calculators, still like these Casios because for most problems, they're easier to use. Okay, let's go to another problem. What if they had said, okay, same problem as before, they said base 10, now they're saying base E, okay? Round to 3 decimal places. Well, Here's the 4, or the 80 and the 4. Okay. Now, 2 ways we could work that. We could use the fraction key, put in natural log 80, close the parentheses, go down, natural log of 4, close the parentheses, get out, equals. Now let's see what they did. Well, they chose the natural log of 80 over natural log of 4, just like I did, which gave us this number and that number to divide. And anytime you round off, you're going to incur a little bit of error. But again, here we have our same number. That 9 rounds the 0 up to 1. Okay. What if we wanted to use this key? Well, log, okay, we did this the other day, alpha E, move over, okay. Well, no, we don't even need to do that. Forget that. You can get that way, but you don't need to go that difficult. Just put in the 4, move it over, put in the 80, or put in the 80, yeah, and hit the equal, and you're going to get that. Because as you see, whether we go base E or whether we went base 10, you still get the same answer. Okay? So this just makes it so simple, that one key. Now we're going to kind of change gears for a little bit. Up to this point, we've been dealing with one-sided expressions. 5, 6, 7, 8, 9, 10, 11, 12. So now we're going to solve equations where we've got material on both sides of the equal sign. Okay. All right. I don't know if I can move that over slightly for now. Yeah, I guess I can. Okay. Logarithmic equations. Some exponential equations, these can be solved using the equivalence property. Here's what it is. Then if b to the x equals b to the y, x equals y, this is something we did before. Okay. This is the one we had where like 5 to the third equals 125, because 125 is 5 to the third. So it's the same value. Problems like that. Well, here are the steps for solving logarithmic equations. First step, isolate the logarithms on one side of the equation. Write a sum or difference. Okay. Change it to exponential form. Check solutions. Okay. Now, as we found out earlier, most exponential equations can't be rewritten to have matching bases. There is a way to solve those with matching bases. At the time we covered the exponential equations, I told you later there would be a way of doing those. Well, today is later. Okay, what you do, isolate the exponential expression, take a logarithm. Let me scoot this over a little more farther. take a log of both sides. Now, remember, you can multiply both sides of an equation. You can divide both sides. You can square root both sides. You can square both sides. You can cube both sides. As long as you do the same thing to both sides, you're okay. Well, you can also put a logarithm on both sides. And then you use the power property. And let's look at these. Now, 50 is not a power of 2. 50 is 2 times 25. So let's look what we did. We put a log on both sides of this. 2x becomes log 2 of x. 2 becomes log 2 to the x. Easy for me to say. And this becomes log 50. Now, using the power rule, I bring this x out front. Okay. Now, what I did here is I need to find what x is equal to. So I divided both sides of this equation by log of 2. So I got log of 50 over log of 2. Okay. Now, this is something we can look up in the calculator. Log 50 over log 2. Whoops, need to use a fraction key. Log of 50 divided by, we'll go down, log of 2. Okay, and we get this 5.6439 rounded off. Notice we have to use an approximate symbol when we round off. Now, you can check this by using this problem right here and seeing if it's correct. Well, let's do that. 2 to the power of 5.6439, 6439, get over, equals, rounds off to 50. And that's why we say it's approximate. Okay. Now, there is one other thing we could have done on this problem. We could have directly changed it to logarithmic. We could have said log 2 of 50 equals x. Okay. What am I saying? I'm saying we could have had log 2 of 50 equals 5.6439, which would have even been easier in this case. So you see, there are multiple ways of getting around this. Okay, let me clear that and scoot it over out of the way a little bit, and then we'll go on. Okay, 2 to the x equals 7. We could go log base 2 of 7 equals in the calculator. Let's do that. Log base 2 of 7. Got to scoot it over so I can see the 7. 7, scoot it over, equals. Okay, that's what our answers ultimately got to come out. So let's go through the steps. Take log on both sides. Okay. Now, I could have, what this disclaimer is saying is I could have used log base 10, which they did use, or I could have used log base 5, or I could have used log base 2, which would have been kind of a nice thing, because 2 of 2 would have given me x equals log 2 of 7, which we put in here, okay? Or I could have even used natural log here and here if I had chosen to. And here they show you an example of using natural log instead. Once again, we use the power rule to bring the x out front, divide both sides by log of 2, so we isolate the x, and it equals 2.8074, rounded. Got to watch my time. When I've got this PowerPoint open, my computer doesn't show the time. Okay, so here we've got an e. So we're going to want to use natural log on this problem. Okay, so we've got this. We're going to take natural log of both sides. First thing we're going to do is we're going to take this minus 0.25w out front. Okay.
This is to notify you regarding your today's purchase on Amazon.com. You have been charged $349.99 on your Visa card. If you have made this purchase on Amazon.com and recognize it, then simply hang up and your order will be delivered to you. However, if you have not made any such transaction, you can call Amazon support right away on 415-651-4389. Thank you.
Blasted nuisance calls. Sorry about that. I did not order that Amazon thing. That's a spam call. Okay, so anyway, first thing I did was I took natural log on both sides. Then using the power rule, I moved it out front. You might ask, well, where'd this natural log e go? Well, natural log of e is 1 because it's log base e of e. So the 1 times the negative 0.25w just leaves the negative 0.25w. Okay, and then the natural log 12 stays over here like this. We want to get w by itself, so we're going to take this and divide both sides by negative 0.25. Here we go. And in the calculator, let's clear this. Okay, we've got natural fraction, natural log of 12. Close it up, go down over negative 0.25 equals. Okay. Is that the only way to do this problem? No, it's not. We could create a log out of this. Okay, we can say that natural log of e to the 12th, log e to the 12th. Well, actually, we couldn't solve this one because of that w and the numbers in there by just putting in one string in here until we got down to this step. Okay, here we go. These are called logarithmic equations. It's just 2 examples of them. Okay, now, before we were starting with exponential, we made them into logs and then solved them. now they're going to start as logs. First, we're going to work with a log on only one side, then we'll work with some logs on both sides, logs, multiple logs, and so on. Now, here's your general strategy for equations like these two up here. You first try to simplify it and see if you can get a single logarithm expression on one side using that multiplication and division and power rule. Then change it to exponential and solve it like we've been doing. So that's your general way to go about doing these. Let's look at this one. Well, we've got a log on one side only. Because we've got a log on one side, we can convert this thing to exponential form. 4 remains the base, -3 is the power, x is the x becomes the solution. Okay, now 4 to the -3 is 1 over 4 to the third, which is 1 over 64. Okay, so that's all there is to it. And here they substituted in 1/64 to see if it was true. 1/64 is 4 to the -3rd. 4 of 4 is 1, leaving -3 equals -3. 1/64 is a correct solution. Okay, look at this one. Okay, here we've got log 2 of all of these are log 2s. Now, I can't solve this like it is, but what I'm going to do is I'm going to use the multiplication rule, since that's a plus there, to get down to just one log. Remember the rule, log m plus log n equals log mn. Only difference is m is just this parentheses, n is just that parentheses, okay? And we're going to now change this whole thing to exponential. 2 is the base, 3 is the power, and that whole brackets is the solution. Well, these two multiply out into x squared minus 1 because they're conjugates. That was easy. It won't always be that easy. Sometimes you might have two totally different things, or you might have a matched pair. 2 to the third is 8. Okay. Now, at this point, we could take this 8 on the other side and have x squared minus 9, which factors into x minus 9, x minus 3, x plus 3, and get plus or minus 3. Or we can use the square root rule, take the 1 over here, take the square root of both sides. Square root of the 9 is 3 plus or minus. And then they did a check of it over here. Now, there's a kicker on this problem. There's something important on this problem. If we put positive 3 in this and check it, it comes out true. But if we put -3 in this problem, then it comes out untrue. Okay? If we put -3 in here, that gives us a -2, and that gives us a -4. Okay? And you cannot have logarithms with negative arguments. You cannot have logarithms with negative arguments. They are I forgot my word. No solution. Okay. Well, let's look at this one. Now, this one is already in exponential form. Okay. This one we can put in the calculator and work it if we want to, okay? But let's just go ahead and go through the steps. We're going to take natural log of both sides. We could take log of both sides just as easily. We're going to move this power out front, okay? Now, we're going to divide by natural log 3 on both sides, and we're also going to divide by negative 0.02 on both sides. So we've divided by the negative 0.02. Here's the negative sign that wasn't in front of these before. And here's the natural log 3. This we can put in a calculator, okay? And to do that, we would have first, we would need the fraction key. Actually, we wouldn't. Let's do it without the fraction key. But we would have to use a parentheses. Natural log 0.07. Close the parentheses. Another parentheses because I've got 2 openings, so I got to have 2 closings. Divided by 0.02 natural log 3, close the parentheses, equals. And you see it. Now, we had to do a lot of thinking on this one. Let's do it the easy way this time. Let's use the fraction key. Okay, we put in natural log 0.07, 0.07, better back up, 0.07, close it up, go down, and 0.02 natural log 3, close it up, equals. So I think using that fraction key in this case was a whole lot easier. But you still have to basically do all of these steps to get to here to put in your values to get your final answer. Okay, it's exactly 12:20 right now. So this is the point where we will take up tomorrow. And that being said, if there are no questions right now, we'll stop from today and